Okay, so we have OpenDNSSEC, which is the main goal of these 3 days. And you may ask, what is OpenDNSSEC? You can basically say that it is a signer in a box, which means that you provide a zone to OpenDNSSEC. It takes care of all the DNSSEC stuff like signing, creating new keys, rolling over to new keys, maintaining the signatures, etc. And then OpenDNSSEC gives back the signed zone to you, and you then do whatever you want to do with it. And you probably want to publish it on the internet so people can access your zone. And you may also ask why we are doing OpenDNSSEC, because you may think that you already have Bind, you have other tools, but the thing that we saw a year or two ago that was that the tools that were available on the internet weren't so good, or they were lacking some special features. So for instance, we didn't have any good key management. You have to do all the manual key rollovers. You have to go into your server room each month to just roll ZSK or etc. And you also wanted to have good policy handling. You wanted to be able to configure the system to do the stuff that you exactly wanted it to do, and don't want to do all those hacks. You just want to have a complete system where you can configure the exact policy that you want to handle. And then you also have the problem with hardware, or when you're going to sign your zone, it takes a lot of operations in order to sign the zone, and you want to do it faster because the zone is growing. You might have bigger keys, which makes the signature timings more longer. So you want to be able to use hardware acceleration for the signatures, or when you start signing your zone, which means that everything will go faster. But you also protect your keys, because then they are stored in hardware as well. Another goal was to have OpenDNSSEC make the DNSSEC deployment more easy, because you just install the software, you configure your policy, and then the software is handling everything for you. So it will be a smaller step in order to start using DNSSEC. But we also wanted to increase the number of DNSSEC users, and one thing is to make it easier to use it, but also providing this software together with this knowledge that we are now giving you with these presentations. And we also been doing DNSSEC for many years, so just gathering all the experience that we have and put it together to this project. So it's not only .se that's working with OpenDNSSEC. We also have Nominet, which is the .uk registry. We have SIDN, the .nl registry. But then we also have NL Netlabs, which are famous for the Unbound and LDNS, NSD name servers. And we have Surfnet, which is a Dutch university network. And Synodon and Cray, which are consultancy, provide some consultancy for us. And the overview of OpenDNSSEC is that it simplifies the process of signing your zone. So you specify that you have this set of zones that you want to sign, and then OpenDNSSEC will take care of it for you. And since you only specify a policy and set what zones you want to sign, OpenDNSSEC will take care of the rest for you, so it will be less work on the system administrator once you want to start to sign your zones. We also provide the software under the BSD license, which makes it easier to take this software and integrate it in other products. So, which means that we spread the knowledge of DNSSEC into other products, because they can use this software. And also, since we are doing the signing in the box, it should be easy to integrate OpenDNSSEC into existing infrastructure, because we want to provide different ways of getting the zone and delivering the zone back to you. And further on, we also provide the key storage and hardware acceleration with something that's called PKCS11, which is a standard interface to talking to hardware security modules. But I will give some more presentations later on what is an HSM and some recommendations on if you're going to buy one. And you should consider OpenDNSSEC as a bump in the wire, which means that it's somewhere between your zone editing, you have your hidden master somewhere, and it's not your public authority name server, because OpenDNSSEC is not currently we only deliver the zone as a signed zone file, but in the next versions to come, we will also provide a real XFR, IXFRs interfaces to OpenDNSSEC. So you have to have some kind of name server in front of it in order to serve the zones. And if you want to give a picture on how OpenDNSSEC works, we have this overall architecture, and you can see the things that I've been talking about, the input zone and the signed zone. Those are the things that you are interested in. You want to provide your zone, and then the internals of OpenDNSSEC will take care of the rest for you. But you also provide your policy, which is the so-called KASP, or key and signing policy. And it's a XML file where you specify all the parameters that you want the system to use. And this one is delivered to the KASP Enforcer, which takes the policy and makes sure that OpenDNSSEC handles the system according to the policy, which includes, for instance, creating keys in HSM, and also telling the signer engine that you should create signatures that look like this, and you should use this key to sign the zone. The signer engine then takes this configuration from the KASP Enforcer and take the unsigned zone, sign it using the keys in the HSM. And then also we have an option to add some auditing on top of this, and that's the KASP Auditor, which compares the unsigned and signed zone so that we don't lose any information, but also that the system has done everything accordingly to the KASP. And if everything is okay, we have a signed zone delivered, and then you can output it on your name servers. I'll go a little bit more into detail about the different parts of the architecture. So we have first the KASP, and that's the policy that you described. So you can have one or more policies, depending on if you have some high-value domains, or if you want to specify different policies for your different zones. But you can also share a policy between many zones, so you can change this accordingly in the zone list that you specify. But in the policy, you have your choice of key strengths, algorithms, signature lifetimes, how often you should refresh your keys or refresh your signatures, TTLs, etc. But you have to load it into the system, and then we have the KASP Enforcer, which just maintains your policy. And that will be just to create the keys using the HSM, but also rolling them in the correct order, because you cannot just move from one key to another. You have to do it in a certain way so you don't break DNSSEC. There are some good information if you want to read how this is done, but it's too complicated to give an information or description here on how you do a key rollover. So that's something that's done automatically by OpenDNSSEC. And once the KASP Enforcer has done everything, it will create a set of configuration that it will send to the signer engine, and that configuration will tell the signer engine that it should use these sets of keys and these configurations according to the policy. We have the HSM, and the HSM should store the keys, so you know where the keys are, so you have a really defined repository of where your keys are stored, so you know that they are exactly here and not somewhere in the system that can be spread around. But it also provides the hardware acceleration, so it will make your signing faster. But it depends if you have those requirements. So, for instance, a large TLD have a larger requirements on the performance than if you only have a small zone that doesn't change so much and are really static, then it doesn't matter if it takes 3-4 minutes, but if you have a really large zone, then it takes some time to design the information. And we have a clean cut because we have the PKCS11 interface, so the user can choose whatever HSM it wants to use. Since they all use the same interface, the user can just provide the correct API. So you can, well, depending on your requirements, you can buy different HSMs which will provide different security levels for you. But in order to not limit OpenDNSSEC, we also have a software-only HSM called SoftHSM. It's free, also licensed under BSD. We have it published on the OpenDNSSEC website. So it behaves exactly as a real HSM, but everything is done in software. And over to the Signer engine. Once the Signer engine has a configuration from the KASP Enforcer, it can start signing your zone. So it will, the main target for the Signer engine is to sign automatically sign your zone, but also to reuse the signatures in order to save some time if you have the time requirements. But also another time requirement is to spread the work over time, so you don't produce all the signatures at the same time, meaning that we add some jitter when the signature are about to expire, so they don't all expire at the same time, and then you have to regenerate all the signatures at once. But it also maintains the NSEC and NSEC 3 chains that you have to have in your zone in order to do the denial of existence proof. And they also updates the SOA serial number for you. But we have different modes depending on what requirements you have. You can, for instance, keep the SOA serial from the input zone. You can use the date counter, or Unix time. But that's all specified in your policy that you provide to the system. And the optional component is the auditor, and it verifies that everything that's done, produced by OpenDNSSEC is correctly done, which is that we don't lose any information, and that we follow the policy. But it's written by a different person using different code, because this one is written in Ruby. The other parts are written in C, so the code, all the code parts are separate from each other. So if there are some problems, they won't affect each other. And then a little bit more about HSMs. And there are two reasons why you should use an HSM. The first one is for security, because now the keys are stored safely in the HSM, so you know that they are located in the HSM, in comparison that you have your keys as a file on the hard drive. Then some you can just easily copy them and use them, the keys, whatever they want. But if they're securely stored away in the HSM, no one can copy the keys. They have to be physically at the machine in order to do something. But then you also get this, yeah?
How many keys can you store in the HSM?
It really depends on the hardware. Well, I think it's about 1,000 objects. So it's one object is either a public key or a private key. So if you have a key pair, then it's 2 objects. So essentially you can store around 512 key pairs.
How is it protected? By a pin or like a normal passphrase or a private key?
That also depends on, usually if you want to do something with HSMs, like creating users, etc., then you have something that's called security officer, and they have a separate privileges compared to what OpenDNSSEC uses, because OpenDNSSEC use the regular user passwords, so you just provide a PIN in order to log into the HSM. But if you want to administrate the HSM, there are different ways of authenticating to the HSM. Some have smart cards, some other have external PIN pads that you can write your PIN codes into. So there are various ways of protecting your HSM.
Can you have different passphrases for the HSM, like the way you do it for OpenDNSSEC, or is
You can create some HSMs can create different key stores. So then you can have, but you only have one user per key store. But I think, well, it's not specified by PKCS 11 if you can only have one user. So I think you can have multiple users in the, but it depends on how they're implemented in different HSMs. Because I think currently, for instance, the SoftHSM only have one user per key store, but you can always create multiple key stores. But the Sun card, I think you can have multiple users in the same key store. So you have to either read the manuals for the HSMs or try it and see how it works. But you have to remember to protect your host, because if they get access to the system, they can still sign the information. So even though the keys are securely stored away in the HSM, the keys can still be abused by someone who have access to the system.
But I guess they still need to have access to be able to log on to the HSM to be able to use it.
Yeah. But we have the pin code for OpenDNSSEC needs the pin code in order to use it. So if they get access to the configuration files for OpenDNSSEC, then they can use the, yeah. And then we also have the SoftHSM. And as I said, we created SoftHSM because we didn't want lock in the users to so they don't have to buy real HSMs in order to use OpenDNSSEC. They can just download SoftHSM and use it as software and use it either as for evaluation, or if you don't have such as high security requirements that requires some FIPS levels. But it's specified or using the same PKCS 11 interface, so it's from OpenDNSSEC's perspective, it's just like a real HSM. It's no difference. Only it's that everything is done in software. And we have SoftHSM as part of the OpenDNSSEC project. So it's just to download the tarball, or if you have a package, it might be packaged for your operating system as well. We use Botan for the crypto library and the SQLite as the database backend, because SoftHSM needs to store the keys somewhere. And then we store the keys in a SQLite database as a file on the hard drive. So the security risk here is that someone might get access to the database that are available on the hard drive. And but in version 2, we're going to encrypt the database and add some more security levels on top of the SoftHSM. So we'll get some more higher security level for SoftHSM. And if you want to integrate OpenDNSSEC into an existing environment, you also have to have some kind of input adapter and your name server. And currently, we only have zone file in, but we also provide a way of fetching those files using AXFR. So we have a daemon that you can configure, and then it will fetch the zone files for you and place them in the correct location where OpenDNSSEC can find them. But we don't provide any way of delivering the zone file besides writing a file to disk. But you can always configure your favorite name server to reload the files whenever you need it, because we have a hook which will be called whenever a zone file is changed, and then you can just, for instance, add RNDC reload if you have bind. But in the, I think it is version 2 of OpenDNSSEC will make this more integrated into OpenDNSSEC, so you can have IXFR, EXFR, connections to databases, for instance, or etc. And when you start using OpenDNSSEC, you first have to, once you have installed it, then you have to configure your HSM somehow. And that really depends on what system or HSM you're using, because they have different ways of configuring the HSM. It's really simple to start using SoftHSMs, but others might have a manual of 60 pages in order to get it up and running. So it all depends on the vendor that you're using. But OpenDNSSEC, from OpenDNSSEC's perspective, it want to use HSM that is initialized and ready to use, and you have all the permissions that you want to use. So you can just give it to OpenDNSSEC in the conf.xml. So you have to do all that work to get the HSM up and running and initializing it. But then the rest of OpenDNSSEC is basically formatted using XML files. So you have the overall conf.xml, where you specify the HSMs that you want to use, the paths to different files, for instance, the policy file, KASP.xml, the zone list. If you're going to use AXFR, then you specify your name service in the zonefetch.xml. And with version 1.1 that we are going to release, we have a release candidate out now. You can also use the EPP client to send the keys up to the parent. So then we have a configuration file where you specify your credentials and also what service to talk with. But that are for those who haven't integrated some interfaces into their own EPP interface. So it's a standalone interface for publishing the keys, so you still have to use your own EPP system in order to create and edit your domains. But since we have a good interface, you can always redirect the function calls that goes to this EPP client into your own EPP system. And currently, we've been working on OpenDNSSEC for over a year. And we had the first release in July, the alpha release. And then we think we had 8 versions of the alpha. Then the beta release came in October. And finally, we had the 1.0 in February. So currently, we are working with the 1.1 release. And we have a release candidate out now. So we're probably going to release the 1.1 this week or next week. And the main goal with this release is to increase the speed, because we had some problems with designing using NSEC 3 because it was really slow. But now I think it went from 1 hour to 8 minutes for the .nl zone, for instance. So it was a really performance increase. And then in 1.2, we're going to work with a new internal engine. So we're replacing the Python parts with C code, so it will be pure C. We'll also work with the key sharing, because now it's somewhat buggy when you're going to share keys between your zones, because if you have like 100,000 zones, you might don't want to create 100,000 keys. You only want to create one single set of keys, and then you want to share it between the zones. But we're going to make that one faster and better to 1.2, because it was a little bit slow in order to create all the configuration for all the zones. And 1.3 will be about better information handling, because now we have various temporary files. So I think we have like 5 temporary files for your zone. We want it to be more faster to design your zone, and thus we don't want to store multiple copies of the zone, just to keep everything in memory and just letting it flow easily through the system. And when we're developing OpenDNSSEC, we try to use different modules. So as you've seen, we have the concept of the policy handling and signing, auditing. That makes it easy to just separate the work between the different developers. But we also try to agree with the interfaces between them, and then you can just easily, if you're not happy with one component, you can replace it with another, as long as they talk the same language with each other. And we also have regular phone conferences with each other. I think it's every second week, depending if we have face-to-face meetings. We also provide code checking before every release with some QWERTY, and also using Valgrind to just check that we don't have any memory leaks. And we also try to have code reviews of the code, so each developer reads the different parts of the code. And we're also now setting up a automatically nightly build system for doing system testing all the time. And currently, we're doing functional. We have some acceptance testing by SIDN, but also performance and system testing by SIDN and .SE. And this is besides the test that the developers are doing. So we have different levels of testing on top of OpenDNSSEC. So that was the overall view of OpenDNSSEC. Do you have any questions about the system design and how everything fits together? Yeah.
Can I just ask, with the HSM, at what level would you start looking to go to hardware? How many zones and how large a zone would you start saying, now you need hardware?
Well, if I compare the SoftHSM with another HSM, I think I've gotten speed like 5,000 signatures per second, and that's quite fast if I compare it with other HSMs. So it's essentially you don't gain so much by going over to HSMs in signing speed. But there are those who can do up to 40,000 signatures. But I think you have to do some calculations on how fast or how often you want to output your zones to your name servers. But I think you can always tweak your configuration to make it faster. So you don't refresh your signatures all the time, that you reuse them, then it will be even faster. Then you don't have to do 40,000 signatures per second. So it really depends on your system. But the decision to use SoftHSM or not is also security requirements. So do you want your keys to be available on the hard drive, or do you want to store it away in the hardware?
That's another question I had. If you're storing it away in the hardware, I understand that it's supposed to be sort of locked from the outside, but what happens in the case of hardware failure with the HSM?
Yeah. Then you have to do some. You have to do backups.
Okay, can you
Yeah.
also standard data backup, or do you need to?
So it depends on the vendor because they have different interfaces. So some are using hot backups, or we call it. So they are synchronized. You have different HSMs, and they synchronize with each other using encrypted channels. Others, you take copies. You have to pre-generate all your keys and then take a copy of the key database, which is encrypted on the hard drive, and copy that database and then import it into the next HSM. But I'm going to have a little bit more presentation about HSMs. I think that's the next presentation, actually.